Hi everyone, let's talk about the divisibility rule for division by 11. This is going to be pretty similar to divisibility by 9, but with an additional twist. The main insight is that 10 to the power of an odd positive integer is equivalent to -1 mod 11, and 10 to the power of an even positive integer is congruent to 1 mod 11, and this both depends on the fact that 10 is congruent to -1. So -1 to the power of odd or even gives you 1 or -1. So let's see what happens when we use the base expansion of an integer. In base 10, we can write n and a positive integer n as am 10 to the power of m plus am minus 1 10 to the power of m minus 1 all the way through to a1 10 plus a naught. And now what's going to happen is that we're going to reduce these powers of 10 modulo 11, and we're going to get am times -1 to the m plus am minus 1 times -1 to the m minus 1 all the way through to -a1 plus a naught. So you can see that the terms have alternating signs. And it's actually not going to matter which one you start with, whether the first one here is positive or negative sign, because they're just negatives of each other, the sum that you're going to get in the end. And I'll show you an example. But the general rule is that 11 divides n if and only if 11 divides sum of digits of n with alternating signs. And we can derive that from this congruence over here. So let me give you an example. Let's say n is equal to 1, 2, 3, 4, 9, 7. Then what we have is that 1 minus 2 plus 3 minus 4 plus 9 minus 7. Let's see, 1 plus 3 plus 9 is 13. 2 plus 4 plus 7 is also 13, so this is 0. But alternately, we can alternate the sums in a different way, which is -1 plus 2 minus 3 plus 4 minus 9 plus 7. This is what I was talking about earlier. And this is also equal to 0 since it's just a negative of 0. So that means 11 divides n since 11 divides 0. So that's how we use the trick for divisibility by 11. Thanks for watching, and I'll see you next time.